Morning, everyone. We are back for today's math lesson, lesson 3.4, use comparisons to solve problem situations. I know it's been a little while since we've had a new math lesson because of the Thanksgiving break. I hope everyone had a great time with their families, and now it's back to reality, or at least our reality for now. So I'm on the page that says use comparisons to solve problem situations. It says number 65, page 65 at the bottom. There's a picture of some dry beans on it, and you'll see that. And I'm just trying to get myself to the right page here. And it looks like this. So hopefully this is working out all right for you guys with your the packets of materials and the lessons all stapled together. What we'll do today here is we're going to go through the lesson together, and then the gray paper from your dark blue colored book that I ripped out for you, that'll be your independent practice. So we'll go through the lesson together here, and then you guys can try that on your own. Okay? So without any further ado, let's get started. So by the end of today's lesson, we should be able to write equations with letters for the unknown values to model and solve multiplicative and additive comparison problems. Okay, it's a big, long statement, so let's break this down to what we're really focusing on here. We're going to write equations, okay, with letters that represent the unknown values. Okay, that's not new. We've been doing that for a couple lessons now. We're going to be modeling and solving both multiplicative and additive comparison problems. Okay, so we're building upon everything that we learned before the break and now taking it to the next step. All right, so let's go ahead and get started. Number 1 says, Anton is making chili for lunch at a soup kitchen. He uses 8 cups of navy beans. The recipe calls for 3 times as many black beans as navy beans. How many cups of black beans does Anton use? Okay, I'll give you a minute to read that to yourself again. And we'll read it one more time. Anton is making chili for lunch at a soup kitchen. He uses 8 cups of navy beans. The recipe calls for 3 times as many black beans as navy beans. How many cups of black beans does Anton use? Okay. Now, for this, they're gonna walk us through the problem here, and this can be a strategy that you can use whenever you're solving these types of problems. But let's just take a look at what they're asking us to do here. Draw a box around what you want to know, then underline the facts you will use. So this is sort of like a strategy that we already do, and I know you've used this before when you're doing word problems. We circle, we underline, we put a box around important information, but specifically they're asking us to draw a box around what you want to know. In other words, the question. So we would box in the question. Okay? That is an important step because that gives us our goal. What are we trying to accomplish? What are we trying to figure out? Okay, so we did that. Check. B says identify the type of comparison. So it said up in the I can statement we're either going to be doing multiplicative or additive comparisons. So what does that sound like to you? Which type of comparison does it sound like? Well, I know that it said that there was 8 cups of navy beans. And it says the recipe calls for 3 times as many black beans. So that's an important bit of information we would want to underline, because those are 2 facts from the problem. So that to me sounds like a multiplicative comparison problem. Multiplicative, because I heard them say 3 times as many. Okay? Now, C says, identify the unknown in the comparison. Circle the answer. What is the unknown? So what is it that we're trying to find out? Is it the smaller quantity, the larger quantity, how many times as many, or how many more fewer? Okay, there's a couple of answers that we can get rid of. Okay, we don't need to know how many times as many because they already gave us that information in the problem. How many more or fewer? Well, that would maybe be if it was an additive problem, but it's not. We're multiplying. Okay? So it narrows it down to us. Now, is the unknown the smaller quantity or the larger quantity? Okay. Well, we know that there's 8 cups of navy beans, but the recipe calls for 3 times as many black beans. So we're going to be trying to find the larger quantity because it's the amount that's 3 times as much as the navy beans, which was 8. So we're looking for that larger quantity. Okay? And finally, not quite finally, but it says write an equation to model the problem. Use n for the unknown. Okay? So the smaller quantity plus how many more fewer equals the larger quantity. How many times as many times the smaller quantity equals the larger quantity. So one thing that we could say is, since it's multiplicative, we could say 3 times as many as the smaller quantity equals the unknown value. Okay? Since they asked us to use n for the unknown, that's why I wrote n there. Okay? That's just means we don't know what number that is yet. Okay? E says solve the problem, find the value for n that makes the equation true. Well, n equals 3 times 8, which is 24. So Anton uses 24 cups of black beans. All right? Fairly straightforward. It's just once we kind of dissect the question like that and break it down into smaller pieces, it makes it much more easy for us to determine what it is that we have to do to solve. Okay? Moving along to the next page, step it out. Oops. There we go. Okay, number 2 says, some students are helping out at a soup kitchen. They bring in 42 cases of water and 7 cases of juice. How many more cases of water than juice do the students bring in? Okay. Now that we've done one, you're probably getting the hang of how you would answer this question. So we now need to identify the type of comparison. So the first thing we want to do is we want to box in what it is that we're looking for. So that's the question. How many more cases of water than juice do the students bring in? Okay. Underlining the important information, it says that they bring in 42 cases of water and 7 cases of juice. Okay, so you've got 42 cases of water and 7 cases of juice. So they're asking us how many more cases of water than juice do the students bring in? Okay, that is an additive or multiplicative. What do you think? Are we going to be adding to using the additive comparison or a multiplicative comparison? If you said additive, you're right. Okay, we don't see anywhere in the question, we don't see anything that says like 7 times more or anything. It just says and 7 cases of juice. Okay, what is the unknown? What are we trying to find? Well, that's within our box here. We're trying to find how many more. Now you might be saying to yourself, how many more? I thought that meant subtraction. Well, let's just go through the process here and we'll see if we can maybe use subtraction. Write an equation to model the comparison and solve the problem. Use n for the unknown. Okay? So I know that the smaller amount of, we're trying to find out how many more cases of water than juice do the students bring in. So we start with the juice. Okay? We start with the 7 cases. So 7 plus something should equal the number of cases of water. Okay? Now, I could, since it is a how many more question, I could now use subtraction to find out the difference or find out what's missing. That's the inverse operation. So I could do 42 minus 7, and I will get 35 for my n. So the students bring in 35 more cases of water. Okay? Now, we've talked about this before, guys. Some of you have asked me, do we have to do all those steps? Well, we're laying the groundwork for what you're going to be doing later as you get older into the higher grades and when you start to study algebra at a higher level. This is the practice that you want to start to get into. So, yes, we do write the equations. Yes, we do write the unknown value, and we show our work on the side to rewrite the equations. Okay? All right, down at the bottom now. I'm going to check your understanding here. So we have 2 word problems where they're asking us to write an equation to model and solve the problem. Use n for the unknown. We're going to follow the same strategy that we have been for the first 2 problems. So let's read it. Start out by reading. Tina donates 3 fewer cans of corn than green beans. She donates 15 cans of green beans. How many cans of corn does Tina donate? Okay. I'm starting with the unknown. I want to try to figure out how many cans of corn does Tina donate. Okay? The information from the problem says that she donates 3 fewer cans of corn than green beans, and she donates 15 cans of green beans. Right? So, to me, that sounds like another additive comparison problem. An additive comparison problem because we are trying to find out how many cans of corn does she donate. And it says that there was 3 fewer cans of corn. So, that means that our unknown value plus 3 will give us the amount of green beans. Okay? So in order to solve, we would take 15 minus 3 and equal n. So that tells me that n equals 12. Tina donates 12 cans of corn. Okay? Number 2, there are 42 students and 6 adults volunteering at the soup kitchen. How many times as many students as adults are volunteering? Okay? Let's see here. I'm going to box my question once again. How many times as many students as adults are volunteering? So that sounds like a multiplicative equation to me this time. So how many times as many? I don't know how many times as many, so I'm going to use n times the information in the problem. Says that there's 42 students and 6 adults volunteering. How many times as many students are there as adults? So we need to multiply the number of adults, which is 6, and that will equal the number of students, 42. Now, just as I was using subtraction, like as the inverse from addition, now I can use division, which is the opposite of multiplication, to find my n. 42 divided by 6 is n. Okay, this is where knowing your fast facts is crucial. So 42 divided by 6 is n. N equals, I know you know, 7. So that tells me there are 7 times as many students as adults. Okay? So hopefully you are understanding and able to follow. If not, I would recommend pausing, reviewing, and going back in that first part of the lesson and watching again. And hopefully maybe you'll catch something the second time that you didn't catch the first time. All right? Now, I would like you to pause your video, and I want you to try page 67 by yourself. Or if you'd like, I'm going to read the questions, and you can pause each question after I'm done reading before I solve. Okay? We're going to write an equation to model and solve the problem using n for the unknown. So just like we were doing on the other pages, except there's not as many steps, so we're going to kind of have to remember what we did in the first little bit of this lesson, okay, using the same strategies. Okay, so if you're going to try this on your own, truly, go ahead and pause right now and check back in with me when you're done. Number 3 says, Mr. Torres makes 12 cups of rice and 8 cups of couscous for the soup kitchen. How many more cups of rice than couscous does Mr. Torres make? Okay, this to me sounds like an additive comparison because I heard the words how many more. Heard nothing about times as many, so I'm going to box in my question knowing that I'm looking for how many more cups of rice. Okay. Also, I noticed that there was 12 cups of rice and 8 cups of couscous. So, how many more cups of rice? So, how many more means I don't know how many more, so it's going to be something plus n. Okay. So, my something is the 8 cups of couscous plus something will give me the amount of rice. Okay. So 8 plus n equals 12. Now in order to find n, I would use the inverse operation. The opposite of addition is subtraction. So 12 minus 8 equals n. N equals 4. Okay. So back to my question, how many more cups of rice than couscous does Mr. Torres make? Okay. Think about what we were trying to find. We were trying to find how many more. So we would say Mr. Torres makes 4 more cups of rice. Okay. All right. I'll go ahead and read number 4 now. Carrie spends 45 minutes making chicken noodle soup. That is 5 times as many minutes as she spends making a salad. How many minutes does Carrie spend making the salad? All right. As we do more and more of these problems, you begin to hear which type of problem it is. Right off the bat, we should be able to tell. Okay. So our unknown value is going to be how many minutes does Carrie spend making the salad? So we box that question in. How many minutes does Carrie spend making the salad? That's what I'm trying to solve for. I know that she spends 45 minutes making chicken noodle soup, and that is 5 times as many minutes as she spends making the salad. So we say it's 5 times something will equal the 45 minutes that it takes to make her the chicken noodle soup. Okay, so now I set up the inverse operation. 45 divided by 5 equals n. Okay, how many times does 5 go into 45? That's what we're asking. Hopefully you know those 5s, and if you know your 9s, you know that it's 9. So we would say that Carrie spends 9 minutes making the salad. Okay? Now, this part down at the bottom is forcing you to read a problem and find a match for it. So it says, draw a line to match each comparison problem to the equation that models it. Okay, this is a difficult skill, but I think that with our ability to now hear what type of problem each one is, we'll be able to solve. So let's take a look at the first one here. Sam has 18 cards. That is 3 times as many cards as Lena has. How many cards does Lena have? So it says, same thing. We're trying to find how many cards does Lena have. Okay, it says that Sam has 18, which is 3 times as many as Lena. So I'm looking for something that says 3 times something equals 18. Okay, which choice would that go with? 3 times something equals 18. Looks like this one all the way down here at the bottom is where I would connect my line. Okay. The second one, Lena has 6 cards. Sam has 18 cards. How many more cards does Sam have than Lena? Okay. This time I'm trying to find how many more cards does Sam have than Lena. That sounds like an additive problem to me. All right. Lena has 6. Sam has 18. Okay. So I am looking for the amount that would say Lena's 6 plus something would give me Sam's total. So Lena's 6 plus something would equal Sam's total, which is 18. Do you see it over here? That would be 6 plus something equals 18. And I see it right here. Okay, 6 plus n equals 18. The third question, Sam has 12 more cards than Lena. Lena has 6 cards. How many cards does Sam have? Okay, I hear another additive problem here. How many cards does Sam have is what we're trying to find. It says he has 12 more than Lena, and Lena has 6. Okay, so this time we're going to take the amount that Lena has, which is 6. Okay, she's got her 6, but Sam's got 12 more than that. So now we have to find one that says Sam's total plus, Lena's total plus 12 more. So we're looking for something that adds the 2 numbers in the problem, which I see right here next to the one I just did. 6 plus 12 equals n. Okay. The fourth question says Lena has 6 cards. Sam has 3 times as many cards as Lena. How many cards does Sam have? I heard he has 3 times as many cards. That's a multiplicative problem, I know. So I'm going to be looking for something with multiplication, which I only have a couple choices left. Okay. So I'm looking for the one that shows me that Lena has 6 cards and Sam's got 3 times as many as that. Okay. So looking for something that says 6 times 3 or 3 times 6, and I see it right up here to give me my total. All right. Sam has 12 more cards than Lena. Sam has 18 cards. How many cards does Lena have? Okay, this is an additive comparison. We're looking for how many cards does Lena have. It says Sam has 12 more cards than Lena. Sam has 18 cards. Okay, so that means we're going to, if he's got more than her, then we could use subtraction to help us to solve, which would be 18 minus 12 is 6. And that would be the equation right up here at the top that says something plus 12 equals 18. That would be 18 minus 12 is 6. So now scooch this line down here through there. All right. And finally, Sam has 18 cards. Lena has 6 cards. How many times as many cards does Sam have as Lena? Okay, I heard the how many times as many, so I know it's a multiplicative comparison, and really, it's my only choice left. But just for the sake of making sure I'm right, Sam has 18 cards. Okay, I see 18 here. Lena has 6 cards. How many times as many cards does Sam have as Lena? 6 times as many right here. So we match it like that. Okay. All right. Well, folks, okay, hopefully reading and listening to those equations has got you familiar and ready and comfortable to tackle these on your own. This is a 2-part lesson here. If you have decided to break this lesson into 2 days, that's an option for you. If you want to just keep on plugging away, then you can continue working and we will plug right along. So we have page 68 is where we're going to next. It's the last page in color in the packet that you've got. So page 68 in your packets for this lesson. And I'll go ahead and read that first section to you. Again, if you have paused this video to do this on your own, then hopefully we're just going over the answers for you now. If you want to listen to the question first and then pause, please feel free to do that as well. So now all we're doing is it's called use structure. So this is where we are practicing the way that we learn how to do this in the problem. So a lot of times, or in the lesson, a lot of times kids will ask me, do we have to do it that way? Well, that's what we're practicing right now. So for this especially, that's what we want you to practice doing. Okay? So Miss Novak volunteers 15 hours at the soup kitchen this week. That is 5 times as many hours as Gina volunteers. How many hours does Gina volunteer at the soup kitchen? Use inverse operations to write 2 different equations to model the problem. Let H equal the number of hours Gina volunteers. Okay, so instead of N this time, we're going to use H for our unknown value. Okay. So I'm going to go back up to the original problem. We always like to read that at least 2-3 times is best. Miss Novak volunteers 15 hours at the soup kitchen. That is 5 times as many hours as Gina volunteers. Miss Novak, 15. That's 5 times as many as Gina volunteers. How many hours does Gina volunteer at the soup kitchen? Okay, so we're trying to find the number of hours that Gina volunteers. So we're going to represent her total, her amount with H. That's what they asked us to do. So we know it's going to be 5 times the number that we don't know. 5 times the number of hours will equal Ms. Novak's total, which is 15 hours. And we know by looking at that equation, if we just think about multiplication fact families, we know that the missing number in that equation would be 3. Okay. Now the directions asked us to do this using inverse operations with 2 different equations. So we just did a multiplication. We would then try to just do the inverse, which would be 15 divided by 5 equals H, and H still equals the same amount, which is 3. Okay. So a statement that answers that question, we could say that Gina volunteers 3 hours at the soup kitchen this week. Sorry, my writing got a little sloppy there towards the end. Okay? All right. Model with mathematics is the next section. Write an equation to model and solve the problem. Use n for the unknown. Okay? We see some centerpieces, some bouquets of flowers there. And it says Joshua makes these centerpieces. He makes 2 fewer centerpieces than Betty. How many centerpieces does Betty make? Okay? Joshua makes these centerpieces. So he makes 2 fewer. So he makes these centerpieces. He makes 2 fewer centerpieces than Betty. Okay? How many centerpieces does Betty make? Well, he's got, okay, so this is going to be an additive comparison, right? He says he makes 2 fewer centerpieces than Betty. So I see 4 here, do you? Okay, I see 4 centerpieces, and he said that he made 2 fewer than Betty. So if he made 2 fewer, then we would need to add 2 to that to find out how many Betty made, right? So if he made 4, which is 2 fewer than hers, that means that the amount that she made was 6. Okay? So Betty made 6. Okay? And the last question here, 2 parts. 5 students sign up to be cooks at the soup kitchen. 4 more students sign up to be servers than cooks. How many students sign up to be servers? Okay? 5 students sign up to be servers. 4 more students sign up to be servers. How many students sign up to be servers is what we're asking here. So we have 4 more than the original 5 equals n. So therefore n equals 9. So 9 students were servers. All right, and the last question for the on your own part. 4 times as many students sign up to be cleaners as cooks. How many students sign up to be cleaners? Okay, so the number of cooks has not changed from the original part, but the comparison has changed. So now we're trying to find how many students sign up to be cleaners. We know it's 4 times the number of cooks, which from the top part of the problem was 5. So 4 times 5 equals our unknown value, and the unknown value is 20. So 20 students signed up to be cleaners. Who would have known? Okay. All right, guys, so that was a long lesson. We're coming up on 28 minutes here, so I know that was a long lesson for you. Hopefully you took advantage of the fact that you're able to break it into 2 parts, 2 days. So if you need to go back, if something did not make sense to you, please make sure that you take the time to go back and make any clarifying notes or anything that you need. You can feel free to join me during our Google Meet, and I will, if you've got specific things that you wrote down from the lesson that didn't make any sense to you, or you just need to get cleared up, please go ahead and let me know. Okay. Attached or stapled to this lesson, you'll also see the gray page from your workbook that I attached in there as well. Please complete that and mark it as turned in when you're done. If you have the ability to take a picture and submit it to me that way, that's even better. That way I can verify that you've completed it and make sure to give you full credit for that assignment. Okay? If you're using Google Classroom on a device like a phone or an iPad, then that should be an easy snap picture, and then you could turn it in and submit the picture right on Google Classroom. If you're using your Chromebook, there is a way that you can submit those assignments. Just please make sure that you follow the directions that went home in the letter last week, and we will try and do things that way. Okay? All right, guys, we'll see you the next time, and have a great day.